Okay, so this handout is all about making the connections between all the maximum, minimum, inflection point stuff, making the connection graphically and numerically to sort of help you guys understand when you get when you find a critical point, what it means or what it possibly could mean in terms of a graph. And so this first problem, it's asking us to label which points correspond to a local maximum, a local minimum, the absolute maximum, the absolute minimum, and the inflection points. And remember, the inflection points, they're kind of hard to spot exactly when you look at a graph, but we could say approximately where they are. So let's first do the absolute maximum and absolute minimum for both graphs. The absolute maximum I'm going to paint in red. So if you take a look at this first graph, the absolute maximum, you just look at what the largest value of your graph is. And why don't I think what I'm going to do, I'm going to retrace the graph, make it thicker, make sure you guys could see it good. And here the graph stops right here and stops right here. So these are the endpoints. Okay, now the absolute maximum is the biggest value of the graph. So right here, this is where the absolute maximum is. And the absolute minimum, you have to be careful, it's not right here at this hump. The lowest value of the graph is this endpoint right here. So this is going to be the absolute minimum. Okay, so now that we've got those down, let's do all of the local maximums and local minimums. So those we're going to do in green. Now one thing to note is that just because this value is an absolute maximum, it doesn't mean it can't also be a local maximum. And remember, a value is a local maximum if it's bigger than every value around it. So if you make a little bubble around it, this value is bigger than everything around it, so it's a local maximum. The endpoint is not considered a candidate for local maximum or minimum, so we don't use that one. And then right here we have a local minimum. Okay, now I didn't ask you guys to find these, but let's just sort of make a note, because this is important as well, is the critical points. Remember that critical points are anywhere where the first derivative is either 0 or does not exist. And remember, graphically, the first derivative is 0 whenever you have a horizontal tangent line. So that means you would have a flat spot. And so wherever you have a local maximum or a local minimum, you're always going to have a critical point. So these two are critical points. But then you also have another critical point, and that's right around here at this flat spot. Even though it's not a local maximum or a minimum, this is a critical point because the first derivative is 0 right here, because the tangent line is horizontal. Okay, so I just wanted to note that, even though I didn't ask for it in the problem. Now the inflection points. Remember, the inflection points are where the graph changes concavity. And if you take a look at this graph, right here it's concave up, but then somewhere around this general area, right around here, the graph starts becoming concave down. And so this is called an inflection point, right here. And remember, this is where the second derivative now is 0 or undefined. In this one it's actually 0, but there are inflection points where the second derivative is undefined. And this is also an inflection point, because notice how it's concave down right here, and then right around here somewhere it becomes concave up. But then right here at this point also, right around here, it becomes concave down. So this is also an inflection point. So notice that inflection points can happen at the same place where there are critical points, but it's not as common as these two. Okay, now let's take a look at this this next graph. Let's do again the same thing. Let's do the absolute maximums and minimums in red first. So the absolute maximum is right here. This is the biggest value of the function. And now here you can't really see, but or you can kind of see, but let me retrace it here. This is a sharp edge, and then we have a hump, and this is a vertical asymptote right here. Let me draw the dotted line for the vertical asymptote. And this is a horizontal asymptote. So I apologize for the graph. It's not very good. Now notice that you might think that from previous classes that functions are not allowed to cross horizontal asymptotes, but in reality they are allowed to cross horizontal asymptote actually many times. And we'll talk about that probably later in class. But for now, so this is the absolute maximum. Now, the absolute minimum, notice that there is no absolute minimum, simply because this guy keeps going down forever and ever and ever. So this means that there's no absolute minimum. Because if this function keeps going down forever, there's no absolute lowest value the function can be. Okay. So with that being said, let's find the local maximums and minimums. Well, here in this sharp edge, we have a local minimum, and then we have a local maximum right here, and then here we have a local maximum as well. And these three are all critical points too. Okay, now for the inflection points. The inflection points, remember, that's where it changes concavity. So this is a straight line, so there is no concavity here. And here it's concave down. And here you continue, it's concave down as well. And then somewhere around here we have a inflection point. Because it's concave down, and then all of a sudden it becomes concave up, and it's hard to see, but it has to become concave up, or else it would not have a horizontal asymptote right here. And so that's it. That's what the all of these local maximums, minimums, inflection points look like. And again, we said this sharp edge is a critical point. The derivative is undefined here. Also, I think it's important to label this one as well. The vertical asymptote is also a critical point. Now, it doesn't have a maximum or a minimum there because it's a vertical asymptote, but notice that it's a place where it changes from here the function is decreasing, and then now all of a sudden after the asymptote it's increasing. So this is definitely a critical point, as well as the sharp edge right here where the first derivative is undefined. And so that's the first problem.